Okay, hello everyone, welcome. It's been a long day, I know, but my name is Jnit Test. I'm from Philadelphia, Comcast Corporation. I'm down here today to talk about brewing espresso with solar power, practical Android testing. Now, it's been a long day, and so as I'm talking for a few minutes, I want to hand out, if anybody wants a piece of brownie, we got until 6 until the food's served. Anybody want a brownie? No? You can take one. Here's a napkin as well.
Thank you.
Right there, yep, you're welcome. Anybody else? Any more brave souls? Okay, so here's some energy to keep you going until we get done this talk. It won't be too long. We'll be done, and we can all just hang out and party from 6 to 8, right, Oscar? Anybody over there? No? You good? Anybody? Any over there? No? Don't? You sure? Okay. All right. Okay, I'm in the wrong. Hold on. So what I'm here to talk about, I don't know how that happened. Let me get back up here. This is what I get for leaving my post. So let me get up here, and then there you go. How's that? Is that good? Okay, so I'm going to start now. Okay, so you got about 35 and 40 minutes or so, right? Okay, so anyway, I'm talking about practical Android testing. Okay, this presentation, you can get this presentation here on this link. Also, my company Comcast is hiring. Okay, so you can go to that link. If you're interested in becoming an Android developer up in Philadelphia, definitely reach out and talk to me after the talk. And we'll have a lot of time to hang out after this, right? We have a big happy hour or happy hours, I think, going on. So as an overview for this talk, first I'm going to go over the good and the bad of testing. This is a testing track, but I think it's good to go over some of these core principles so we all know where we're coming from, right? So we're going to do the good and the bad of testing. Then I'm going to cover the who, when, and the how of testing. Who's doing the test? Who's writing the tests? When are they writing them? And how are they writing them? Okay, then after I get that groundwork covered, I'm then going to cover practical espresso testing. And so I'm not going to do the nitty-gritty, how do you install espresso and what is the DSL or the syntax of the language. I'm going to get into rather the common ways in which we should use espresso and ways in which we shouldn't, right? And as we learned in our keynote earlier today, 22% of you in this room will be more likely to remember what I say if we involve it with a story of some sort. So I'm going to dive into my case study application that has to do, as you might have guessed from the title, with solar power, okay? So hopefully it's sunny up in Philadelphia today. I'll tell you why in a little bit. So first, I like to end on a good note, so I'll first talk about the bad of testing. Okay, so the bad of testing is that testing triples time to develop your minimum viable product. Okay? Testing also makes changes to your production code take longer. Testing also requires your developers to learn a bunch of additional domain-specific languages and frameworks in order for them to write these tests. Oh, yeah, I don't know why it keeps happening. Sorry. How long has that been that way? Okay, is that good? All right. Okay. I see why. Okay, let me do this. There you go. Okay, now you go. Okay, well, frowny face. Okay, there. Also, for some businesses, testing doesn't work, right? For example, a startup where they had their minimum viable product is they had to go to market with that because they're going to lose their B round of funding or they'll go out of business. So sometimes testing doesn't, and I appreciate that, it doesn't always apply. Okay, now for the good of testing. Right, the difference between a minimum viable product and a finished quality product is testing. Quality products are delivered faster when you include testing in your development process. Also, code changes are less likely to break your product, and that's because your product is ensconced with all these tests, right? And so actually this is a cool thing. A lot of tests that actually emboldens your developers to write better code, to improve, because they're more, and I actually had this recently, someone wanted to refactor a bunch of our code they hadn't written in our app, and I said, go ahead, just go for it, because we have tests, and it gives you a level of confidence to do this kind of thing. So when you do this gradual improving and refactoring of your code, you end up with a better product overall. So all these reasons actually are why you end up with a better product with testing. So now let's talk about the who does testing, when they do it, and how. Okay, who writes tests? So bugs found by external post-development QA groups are very costly to fix, right? And this is because there are different groups or different organizations. You have your QA group and your dev group. Okay, and so you have, we have bug reviews, you have all this kind of context switching that goes on. It's really just too late in the process to find your bugs. So what you'd rather do is you'd rather find your bugs during the development process, right? You want your developers to write the tests and fix the bugs. They can do this faster, right? And this isn't because developers are better than QA engineers. What I'm suggesting is that you take your QA process and move it back into your development process, and this is called shift left testing. Right, so you just want to embed your QA group, your testers, in the development process. It's important. Okay, so when do we write tests? This is somewhat of a controversial subject for some, but code and tests in general should be written about the same time. Some folks think you should write your test before you write your code. I actually don't believe in that because I think it inhibits the agile process with soliciting feedback from your stakeholders, even with code you haven't even checked in yet, right? So, but certainly, your test should be written before you, for example, submit your code up for master, for merging to be used by others. It should be tested, right? But the important thing here, regardless of what you think about this controversial issue, the important thing is that you keep testing in mind when writing code. And what I mean by that is you want to write test-friendly code. Okay, so how do we write test-friendly code? Well, remember, your goal with testing is to test your target application in all possible situations, right? That's what we want to do when we test. And so to do that, you need to control your external dependencies, right? The external collaborators of your test subject, right? And the best way to do that when you're writing your code, when you're writing your production code, is isolate your external collaborators. And the most common way of doing that is passing them in, for example, in your constructors, right? So instantiate an object, you pass in your external collaborators. Right. Also, you can use dependency injection such as Dagger to inject them as attributes. But either way, you want to keep them all kind of isolated. What you don't want to do, for example, is have your code riddled with static singletons and static references, right? Also, you want to do minimal work in your constructors as a general rule. And part of that is about, when you instantiate an object that you want to test, and then sometimes you're going to be inserting mocks after that. And so if those mocks will miss any business logic you have in your constructors. So you want to keep your constructors very simple. Often I just have my Dagger injection stuff in my constructor. And here's actually the most important part, is when you're writing your test-friendly code, you want to use access modifiers. And by what I mean by that is, you want to isolate your methods. If you have a method that's doing private internal logic that's only necessary for that class, and it's at this moment, it's not being used by anyone else, make the method private. Now, this is not just a good idea for OO, right? Encapsulation, information hiding. It's also good for testing, because what you're doing then is you wind up squeezing into the smallest number of possible public methods that you have, the smallest possible number of public methods to express the public interface or contract to this class, right? And that's really useful because actually when you go to start to write your tests, you're going to be writing your tests against these public methods only. Right? You're not going to write tests explicitly to test these private methods. So I guess what I'm trying to say here is, another way to think about this is you're explicitly testing behavior in your app and only implicitly testing implementation. Again, this is also somewhat of a controversial area. I might get some arguments about this, but it's the end of the day and I'm talking, so I get to set the rules. So you're explicitly testing behavior, implicitly testing implementation. And this is critically important. This implicit testing, so obviously if you're writing all possible permutations of your input or your public methods, you're implicitly going to be testing your private functionality, right? But anyway, this implicit testing, this helps to keep your tests flexible or less brittle. This is an important concept of testing, is flexibility and less brittle. Okay, so why do we like flexible tests? Why don't we? What's wrong with brittle? Although it sounds kind of weird, except for you're talking about peanut brittle, which I happen to love. But anyway, in fact, I had peanut brittle here last night. Was anyone here last night? The hotel was giving out peanut brittle. I didn't get that. But anyway, back to the point. So the reason why you like flexible tests is because what it allows you to do is you can actually change implementation often without even require any changes to your test. And this is a wonderful thing. If this is the coolest thing ever is when you've gone in, and George might know what I'm talking about, he does tests. And so you could change your implementation in usually minor ways, or refactoring, and your tests don't break. That is the definition of flexible tests, right? For example, you can actually refactor in situations like this. Again, this is because of implicit testing. Another concept that I want to bring up with review with testing is you want to test real objects. Okay, so you create a real object, you inject the dependencies if they weren't passed in during construction, and then you test. Right. So an example here is this class main activity view model, which I'm passing in an external collaborator into the constructor, and then I test. That's the general way of doing things. Now, sometimes external dependencies are not so easy to extract. They're not so easy to mock. Okay? An example is Android activity, right? You're always deriving from a base class, and there's methods that there's derived methods that are there. There's context resources, so you can't extract out the external dependencies, right? Now that's a problem. You can't instantiate the activity. So one might be tempted to do what's called spying, which is instead of instantiating the real object, you instantiate a spy. And what this is kind of a hybrid object. What it does is it allows you to test one method while mocking adjacent methods, right? Some folks use this when they're retrofitting old code with tests, right? They'll just kind of march through the methods, test, 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 mock, 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 right? Now, the problem with that is it leads to explicit testing of your implementation again. What you wind up doing is marching through every single line of code, and you do what some call reverse implementation testing. You're basically just writing your code twice. This leads again to brittle tests. So this means that every time you touch your code, you break a whole bunch of tests, right? What was that thing we did? Oh no, what was that thing we did in Keynote? Oh no, whatever. So does anybody remember that term, that phrase? Yeah, right. Ta-da! Was that good or bad? I thought that was, anyway. So you just get this moment where like your tests are all broken because you touched your implementation. That again, not to harp on this, but that is a brittle test. So again, spying, partial mocking is another term for this. This is what causes this, right? So what we need really then is an Android-aware environment that we can run, where we can stand up our Android components. Okay. Again, we don't want to dive too deeply into our implementation when testing. This is a great segue into the main topic, which is Espresso. So let's dive into Espresso. Who wants to hear about Espresso? I need to get some life. Hey! Okay, so I've been remiss here. I missed something, and that is I have these fidget spinners that I made. They're 3D printed fidget spinners I made with it's wooden 3D printer, so there's a skateboard bearing. They're very cool, and I want to give some of these out. So I have a bunch of who would like a fidget spinner? All right, we're gonna get some of these out. Okay, excellent. So quick, who can tell me what is good? What's a good thing? Brittle tests or flexible tests? Flexible tests. All right, good job. Here you go. All right, good. That was kind of a gift, but whatever. That's cool. Okay, so I'll get more of those out. I have like 1, 2, 3. I have 5 more. So cool. Okay, so practical Espresso testing. So what is Espresso? How many people here have used or actively using Espresso in their work? Okay, fair amount. That's good. Now I don't want to assume anything about any of you except that you're all wonderful people for being here. But you know, this isn't about how to write Espresso. This isn't about how to use Espresso. It's how to use it effectively. So I've come to the conclusion, right? So hopefully, maybe even some of you who are already using Espresso, I can influence you in some way, maybe, or maybe modify how you're using it, because it's very easy to stand up and start using it, like a lot of things, right? Like a bicycle, right? Whatever. So I have no idea where the bicycle came from. I like biking. Anyway, so incidentally, I did bike here I biked here from Union Station in Washington D.C. And I carried these all that way. So these fidget spinners have been ridden in saddlebags from DC, all uphill apparently. It's a big hill from here from DC. So anyway, I digress. So Espresso is part of Android's UI testing framework. Okay, and the cool thing, right, is that you're testing behavior of your code on a real Android device. That's what we're talking about, right? That's what's helpful. Now here's the thing, here's the catch. Espresso is slow. It's certainly slower than JUnit. So that's what this talk is about. It's not about whether or not you should use Espresso. Yes, you should. It's about how, right? So let's go into the basics of Espresso. Espresso testing involves for those of you who didn't raise your hand and are interested because you're here, Espresso testing involves 2 applications. You've got your target application, your code, and you've got your invisible test application, which contains your tests. Espresso actually creates 2 different APKs and installs those on a real device or an emulator. And then it runs your tests. So let's talk about those tests. So the test app sets up the conditions for a test, right? The test app then goes and finds the view elements on your target app. It performs some view actions, such as clicking a button, and then the test app has to wait for the target to react, right? The test app has to wait for your target to process this button click. Show progress, spin, or whatever. And then finally, your test app can make assertions which either pass or fail your test. So this waiting I'm talking about here is actually kind of important. So let's talk about that. In fact, let's call it the waiting problem. That doesn't bode well, right? There's an ominous tone there. So the problem is the test app and the target app are running on different threads on the same device, right? So after performing an action, the test app has to actually wait, right? And the question is, how long should your test app wait for the target to react? So one might be tempted to use thread.sleep. Who here has used thread.sleep in a test app? Okay, this person here, why is that not good to use thread.sleep? And you should know that either way you're going to get this fidget spinner. Okay.
Because it's inconsistent.
Awesome. Keep going. Sorry.
It just depends. It's like randomized. Seems like sometimes it'll take 5 seconds, sometimes it'll take 7 seconds.
Great. Good job. Stop stealing my show. All right, great. Good job. Yes, exactly right. Everything you just said was perfectly correct. Randomized, inconsistent. This is a problem with tests. People who do testing a lot know that the biggest problem you have is inconsistent failures, right? And that's Giorgio's nodding his head. Unless you were falling asleep, I wasn't sure. You're nodding head in agreement. Okay, good. So yes, so basically, you put in 250 milliseconds because you want your test to be fast, but it's not long. A week from now, someone adds code somewhere else and your test fails. Now, because remember, this is Espresso. It's your real code running a lot of times, right? So thread.sleep is not good. You want to avoid that. And the people who made Espresso knew this a long time ago, and they've come up with some solutions. So let's talk about those. Espresso synchronizes, right? Espresso will actually automatically make your test thread wait while your target thread reacts. How cool is that, right? It's very cool, in case you were curious. So specifically what Espresso does is it actually tracks the target threads, your target application's main UI looper, and it looks for all the immediate scheduled runnables to be finished. So if you have something delayed runnable, it won't wait for that. Like if you say run on main thread in 5 seconds, it won't wait for that. But all immediately scheduled things it'll wait for. So that's great, right? So now if you click a button while the on-click in your main test is being processed, the on-click method, while that's running, your test is going to wait. Isn't that cool? Now some of you might be saying, what's the problem? Okay, I'll just go on. So some of you might be saying, what about if I'm doing background work, right? So good question. What if your target app is also performing background work when you click that button? Espresso actually also synchronizes this as well. By default, what it does is it synchronizes your test thread against the thread executor used by the async task, right? So if you do async task, run something, your test thread will wait for that background work to run as well. Everybody get that? We cool? You follow me? Awesome. Double whatever this is. Okay. So now who here has a problem with async task? Okay, good. We got some people who have problems. You're not just saying that because you think you're going to get a spinner, right? All right, so some people who may not like async task or, whatever, and it could be used in certain situations to good effect, certainly, but you might be more into like RxJava for backgrounding. It uses the same mechanism, and I'll show you how to do that when we do a code walkthrough in a little bit, okay? So I'm just going to spin this while I'm talking here to annoy everyone. Okay, so now sometimes this synchronization won't always work, right? There'll just be some problem with this automatic stuff, and you'll have to then fall back to this thing called idling resource. Now, the idling resource is a way for you explicitly in your production code to say, I've got some weird black magic going on in my background, and I can't really synchronize it with your async task, whatever thing you're talking about, so I need to just explicitly say, my app is busy right now. Excuse me, all this water. And at some point in the future, when I think my voodoo black magic thing is done, I'll say my background, my production code is now idle, right? So you're explicitly declaring whether you're busy or idle, so that the Espresso knows what to do with the test thread, right? So who can see this is actually called an anti-pattern. I believe this is an anti-pattern using idling resource. Who can tell me why it's an anti-pattern? Who can tell me why it's bad to have idling resource in your production code? And it can't be Giorgio. Anybody? Yes? Oh, snap. Exactly. Here you go. Spin. So it's polylactic acid, all the plastic in that. It's made from cornstarch. It's biodegradable, and the wood is, I don't know, it's just wood. Half-inch steel ball bearings and skateboard bearing, sealed bearings. Anyway, so I digress. So that was an excellent answer. You don't want test code in your production code. So by doing this idling resource, your code is actually implying a certain test framework. And that's kind of an anti-pattern, but sometimes you can't help it. So it's there, it's needed sometimes. I actually, in my test code, I'll show you in a little while, I needed it, right? But it should be avoided, okay? Okay, now, testing is about setting up your mocks. So let's talk about that. The test and the target apps share the same process space. This is really important. The test and the target apps share the same process space, which means your test app can affect the shared heap, right? Your test app can actually hack the target app's dependency injection, the object graph, right? Who uses, what do you use for dependency injection on Android? Oh, that was too easy. Nobody's getting a fidget spinner for that one. Excellent, right, thank you. That's right. And so the cool thing about this, right, is your test app can actually change that Dagger graph. It instantiates the thing it wants to test, and then it may, like, mess with the object graph before injecting it. Now, it's kind of like this is a superpower thing. It just is like, with great power comes responsibility. Like, like your Wonder Woman with a lasso, or the thing she has is bangles, whatever they're called. So it's a really powerful thing using mocks, especially in Espresso. It's really cool. You can, like, stand up your app and then mock with anything. But actually, that's actually the next big part of my talk is like when to mock, because you can do it wrong, you can do it at the wrong time and use Espresso ineffectively, right? So the question is, which parts of your target should you mock? So that gets to my 2 types of Espresso tests that you should write, and only 2 types. The first is unit testing Android components, such as activities or services, right? The second type of Espresso test is an end-to-end user, right? So let's talk about that. Let's talk about the unit testing Android components first. So again, Android is our Android-aware environment, which helps us to avoid spying. That's what I talked about, right? It'll let you stand up an activity, and it lets you control your dependencies. And Google's been tested, so your get resources call, it's going to work. Trust me, right? So, but remember, JUnit is faster at testing business logic. So you really don't want to use Espresso. When you're unit testing Espresso, when you're unit testing your Android components, you want to have as little or no unit test as possible in those business logic in those unit tests, right? And this means you want to make your Android components as small as possible, again, because Espresso is slow. You don't have to write too many tests. So let's talk about specifically an activity. It's the most basic example, right? So let's talk about unit testing an activity in Espresso. You want to shrink your activity as much as possible using some kind of, many reasons why you have these frameworks, MVP, MVVM. So I'm going to recommend here model view model approach, right, which is MVVM for short. And so Android architecture components helps us with this. Specifically, now the nice thing about doing a real late presentation is you get to draw upon all the talks that have happened throughout the day. So I know you've all heard the term view model, at least once. Who here has heard the term view model today at some point? Okay, excellent. Okay. So a view model is a great way to extract out not only business logic, but state from your activity. And it's kind of amazing, the transformation. I did this with my app, which I want to show you. And I think my activity was like 280 lines of code, and it went down to like 110 lines of code. And there's no if statements in my activity, right? So, because not only was I extracting business logic, but UI logic, right? Just anything having to do with like depending on modifying text to fit a certain need, like all is done in the view model. So then therefore you have your activity and your view model, and that's it. The only external collaborator now for my activity is that view model, okay? The other type of testing is end-to-end user testing. It's the second type of Espresso test that you should write. And in this example, you're leaving the target app completely intact. You're not mocking anything of your application. You're just standing it up in Espresso. Now, this is a large test scope, right? It means you're standing up your app, and this is kind of interesting because if you think about it, you're standing the whole thing up. If you're not mocking anything internal, That doesn't mean you can go right to your fourth activity in your app. You have to actually start at the beginning of your app in your test and navigate through the app in your test to get to the activity you want to test, right? So it's kind of difficult, and it takes a long time to run. And if there's a bug, if there's a failure, it takes you a long time to track it down. But the great thing about it is it's an integration test of all your different components. So you do this at the end of your dev cycle after all your unit tests are done, right? And your external dependencies here can actually be real or mocked. So when you first start writing these tests, you might want to use real external dependencies, such as a real website or real hardware or something, and you write your Espresso test. Oh, cool, my Espresso test works. Great. But they're not, these kind of tests, they're not repeatable, they're not dependable, right, which is important. So you in general, you want to mock your external dependencies when you're testing with Espresso in this way. And again, remember, this isn't talking about mocking a view model with the UI with the unit test. I'm talking end-to-end testing. So our mocks are these external things. So what's the most common thing we're going to mock externally in our application? Who can tell me? Cool. I was looking to see if it was up yet. It wasn't. Who said that? All right, awesome. Exactly. So typically the thing you want to mock when you're writing these end-to-end tests is you got to spin it like this. Very important. None of this stuff. You can do that, but you really want to do it one-handed. It'd be cool. All right, either way is fine. I'm kidding. Oh, you did it. Okay, fine. You'll work on that. Okay, so anyway, yeah, so MockWebServer is yet another Square library. And this is what is typically used in this situation. It's a scriptable web server, right? And you basically use it to replace a RESTful endpoint. And we configure, the cool thing is you configure it for each test. You configure one of these things. And that means you configure the input and the output. Given a particular request, what's the output? What's the response, HTTP response? The cool thing is you do this inside of your test. Each test, you deploy one of these servers. So you've got your test APK running, your target APK running on your device or emulator, and then you have this web server running on inside of your emulator, pretending to be the outside world effectively. So I think that's pretty cool. So that actually covers the run-up to this case study application that I want to talk about, right? So, so last year, I had solar panels installed on the roof. Let me see, is it sunny outside? I need to look see if it's sunny in Philadelphia right now. Yep, it's 91 too, but that's not as important. Okay, so last year I had solar panels installed on the roof of my house, right? And it was a really cool experience. And for some reason, National Public Radio did a story on it, and so there's all these reporters, and this guy on the left here is clearly a construction guy. He's got a hard hat and a beard, and he's installing solar panels on my roof. And I look like, that's me there. I look like one of the members of a gang or, I don't know, a band. Anyway, but it was a pretty neat experience. So, what was cool about this, and this is a cool story that kind of helped you remember the subject matter, okay? Well, maybe not cool, but it's a story, okay? Anyway, so this app's called Solar Monitor, and what the point is, I wanted to track the electrical output of my solar panels. I wanted to just walk into my house and, and see how much power my solar panels are producing. And I didn't want to have to enter in like, oh, my solar panel ID or my customer ID. I just kind of wanted to play around with some different ideas. And so what I did was I had a Bluetooth beacon, which is right here, by the way, Bluetooth beacon. I don't know if anybody can see this. It's very sorry, that was loud. I apologize. Very small little beacon. And so this actually, I stuck this inside of my solar panel up at my house. I actually carried it down here. So we all have to imagine that we're in my house right now. It's a very big room in my house. And this beacon is somewhere in my house. It's stuck to my solar panels, okay? So, so I walk in the house. My application picks up the beacon and knows all the information it needs about my nearby solar panel, right? So all the the information it needs to then go out and load the latest information from the cloud about this solar panel. So it's kind of like automatic detection, picking up my solar panel and then going and getting this information, right? So I thought this was a great case study. So this was kind of fun to write, but it was also a great case study for testing because there's a lot of external dependencies. It has the hardware dependency of scanning for Bluetooth, and it has this external dependency of going out to the cloud to this RESTful endpoint to get my solar output. And I want to give you the code a little bit. I'll show you the code. In fact, let's do that next. Here it is. Whoop, okay. So that's a GitHub repo that you can look at this code. And so a lot of the details are, what I try to do with this app is not make it super, super complicated. It really just focuses on the bare essentials of Dagger and of our Android architecture components such as ViewModel and Espresso. So over time, I might make it more complicated, but for now, it's just about Espresso. So it's a great place. You know, a lot of these like GitHub projects, look, they're just huge, and they have everything in them. It's really hard to kind of slice out the part that you want while having to learn like the latest way of using Dagger, and you know. So this uses Dagger in a fairly a way it's been around for a couple years anyway. So hopefully it won't be too confusing. So let's dive into this. So remember, the app does two things. It scans for a nearby solar panel, right? This thing, and then it loads its current output. So now I'm going to, let's go over here. Oh, look at a frowny face. Okay, hold on. Let me plug this in. That's the wrong plug. Here it is. Okay. Okay. Everybody see that okay? Okay, so now this is the first state that the device, this activity has 5 states. This first state is like, hey, click the load. So I'm going to click the lower right button here. Okay, so now it's, okay, it actually fails the first time. Don't ask me why, it's a problem with my library. But anyway, so you click on it again, it's my scanning library and Bluetooth scanning. So I click it again, now it's actually scanning for this beacon. It's looking for my panel somewhere in the house, hopefully on the roof, and it found it, right? So here it is. Actually, this really just did happen. I'm not making this up. It scanned for Bluetooth. It got the panel ID, and now it's got it going to Google Proximity API in the cloud. It went and got the configuration information about the panel, and now it's in a different state. It's no longer in a loading state. It's now in a state where it's saying, do you want to go and get the data? So now it's produced another button on the bottom right. So I'm going to click on that button. Now it's going to the cloud to get the current output. So right now, my system is producing 40 cents an hour of electric power. It doesn't sound like much, but if you add up every hour, it's pretty good. So already, it's not even been up in a year, and it's already made me $1,000. Unfortunately, it costs more than $1,000 to install. But we won't go into that. It'll be a few more years. Okay, what did I just do? Okay, hold on. So now I'm going to go back. I have a little bit of like screen match to do here. Okay, so sorry, let me go back one. Right. Okay. Great. So notice there was one activity with 5 states, right? Click the scan, scanning, and then that second button showed up. Click the load, loading, and then it gave me the output. So these are 5 states that I know I need to test. Remember, I'm doing what I want to do first here is an activity unit test, and so I'm just going to consider these 5 states of this activity because that's all my activity is doing. Is showing these states. It's not doing a lot of business logic. So let's look at this first test, an activity unit test. And remember, again, I want to dive into the code now. Yes, we're actually going to see code. We're going to dive into the code. And remember, this is a small activity with a mocked view model. So let's go ahead and look at the code. Okay, I need to do one thing here. I want to mirror my displays such that I can do this. Okay, everybody see this okay? Now, don't worry. I'm going to put it in presenter mode, make it a little bigger. Okay, how's that? Everybody see that okay? Kind of? Okay, everybody good? How about you guys in the back? Is that okay? Okay, you got a thumbs up. Excellent. Okay, so this is an Espresso test. I know maybe like 10, 8 of you have done Espresso, but a lot of you haven't. So that's fine. We're going to dive through some of this real quick. So the first thing, so Espresso, you have these rules. They're actually JUnit rules. But these rules are what kind of set up your Espresso test. They're rules that kind of pervade the whole test. All your tests, the whole suite of tests. And so this rule is very important. This is the activity test rule. This is the thing that says which activity you're going to stand up. And remember, we're doing a unit test for the activity class, right? So we're going to stand up this activity, okay, my main activity. And then notice this false here. What that means is it's going to at the beginning of the test, it's going to instantiate the activity, but it's not going to start the activity. And that is, the reason for that is because I want to do some mock stuff before I stand up the activity, right? Remember we talked about that. So this instantiates the test class, the class that we're going to test. Okay, now also I want to talk about this guy. This is another rule. And this rule is for those RxJava folks of you out there. And what this rule does is it says, so those who use RxJava, you're familiar with the I/O scheduler and the computational scheduler. What this rule does is it says, use the async task thread pool executor for these schedulers. So it's essentially doing that synchronizing that I was talking about before with async task. So now even your RxJava background threads are also synchronized with your test thread. Okay, and remember, that's about making sure your test thread isn't progressing while your target is actually doing something, okay? Okay, so now I want to zip down to here. I'm jumping around with this code. Try not to move it too much to give you motion sickness. I just want to go nice and slow through here. Now remember the other thing I talked about was how the test app can actually hijack the object graph of your target, right? Do you remember that? I'm trying to keep it. By the way, does anybody want a brownie? I have brownies here. Anybody want a brownie? Raise your hand. We had some newcomers here. I have brownies here. I didn't bake them. I just stole them from the lobby. Okay, so this is hijacking the object graph of the target application, and so here's this cool thing you do: get instrumentation. And this code. Remember, this code you're looking at is the target app. It's the target thread. Okay, but here I have a reference to the. I'm sorry, this is a test app. I said that wrong. I apologize. Good thing this isn't a confusing subject. This is the test application you're seeing here, the test code. But the cool thing is here I have a reference to the target application. This is that hacking I was talking about. So what I want to do is I want to create my own object graph specifically for this test. And the only thing I'm mocking, who can remember what I'm mocking? So who's paying attention? Oh, no, okay, so this is a unit test. Thanks for asking. Who said that? Did I already give you a spinner? Because I'll take it back if I didn't. No, I'm just kidding. No, so I appreciate the answer. No, that's the next test. But you know what? You spoke up, so you're going to get one anyway. Yes, you're getting an award for being wrong, basically. That's okay. Thank you. I love you. It's awesome. All right. So this is a unit test. So remember, I have my activity class, which I'm standing up in my emulator or real device, and I have this one other thing I'm mocking, and that's the view model. Right? Remember, it's the first type of Espresso test. One of the two types that I'm endorsing here is an activity unit test. I have my activity. I have my view model. So I'm mocking my view model. Okay. So this object graph. It's going to just, I'm not going to go too crazy here in Dagger, but it's extending my object graph, the normal production object graph, and all it's adding to it, it's overlaying on top of it my mock view model, okay? And then here we go, I assign that object graph to my target application. So now before my test starts, this is in setup, by the way, of the test. So before the test actually starts, I'm standing up the main activity in my target app, right? I'm injecting my mock view model, okay? And here I actually configure that. Here's a cool line of code here. They're all cool lines of code, right? So I say. And so here what I'm doing here is I'm actually injecting the test class. I'm injecting this test into the same object graph so that I can conveniently get access to all the mocks that my Dagger graph is injecting into my target. They're also injected into my test code, right? So here it is right here, in fact. Here is the mock view model, and here I'm setting the initial state of idle, which is that first state you saw when it started up. It was waiting to scan for Bluetooth. Okay, so it's late in the day. I don't feel like looking anymore. Who feels like looking at more code? Yeah, we're close. We're close, right? Yeah, we're close to being done. Who's here is done and ready to have fun and relax and forget about code? Sorry, I'm kind of lame. I know. Anyway, it's been a long day. So these are those really small tests that I was talking about. Because we've done this great job of shrinking my activity, the tests that I have to write in Espresso for this activity are very small and very fast. Because remember, Espresso is slow. So this is testing the idle state. And all I'm doing is I'm making sure that the activity is just drawing the right images and showing the right text and turning on the right buttons, right? It's a very simple test. Now here is where I'm starting to change. I'm starting to assert changes. I'm starting to change my my mock to do different testing. So here I pretend that the person clicked on scan for beacon, and when they click on scan for beacon, they're going to get back a value of scanning for the state. And remember, all my activity is doing is responding to state changes. So it doesn't have any real logic in it other than like a case statement, a switch statement, or a when, if you're a Kotlin person. And here we go again. So my point is, I didn't write all these tests, but my point is there's not much testing to be done in the activity, which is good. Okay, how far? I think I'm pretty good on time now. I could show more end-to-end testing, but I think I'm about 30. I should stop now looking at the code. So what I want to do, sorry, I made this all ugly here. I knew I was going to do this. Here, let's try this. And then I'm going to, oh, right, okay. Anyway, here we go. We're done. I'll show you my speaker notes. How's that? Is that cool? No? Okay. Okay. Anyway, I'm going to show just that. Whatever, here you go. Just leave that screen up. I knew the screens would confuse me. But anyway, I'm done. We have a few minutes left. Who has questions? Any questions all about Espresso or testing or 3D printing, anything? Yes? Yep. Yes, that's what I skipped because I didn't want to subject to any more code. So Bluetooth is actually not really easy to mock in an emulator, and so you want repeatable tests. And so if you're using a real device, you need real Bluetooth a beacon. And you would not want to produce tests depending on beacons, right? Dependable, repeatable tests. So so I lied. It's all ruse. Actually, I lied. I did mock a very thin layer, and that's probably what you're wondering. I mocked a very thin layer of my application that has to do with beacon scanning. There's no other way around it. You could try to like mess with this is always this challenge with Espresso. You could try to hack your emulator and add some kind of addition to like Genymotion or something to make it kind of produce mock results. But that's also problematic because now you're starting to have Genymotion API code in your test. And so what I did was that you make your hardware layer as thin as possible, again, without any business logic, and you have your really thin hardware. And this is one of those things you do with testing. You make compromises. So you have a really thin hardware layer in my code that basically abstracts out the Bluetooth code. Like, for example, the Bluetooth manager, I have a mock version. I have like a proxy layer. It's like an interface that says, I am the Bluetooth manager. And then in my end-to-end testing, when I mock out my external collaborator, I use a mock version of that Bluetooth manager that says, yeah, you got Bluetooth, no problem. And then it says, yeah, you found the beacon, sure. So I mock out that stuff. So thanks. That's a great. You honed in on the one thing that I lied about. Thank you. Yes.
What are some ways that you get around when you can't find elements using Espresso? Like for instance, like I had this situation where I'm trying to tap on tabs, and like you don't have an ID to find it. So like I'm trying to avoid changing my code so that I can click on the tabs. But are there some popular situations where we just can't find it?
Yeah. So So it's great. And what's your name?
I'm Trenton.
Trenton. Since I've given you like free stuff and you've answered, I'll just get your name. All right. So Trenton. It's been a while since I've written code for tabs. We have it somewhere in our app, but basically, yeah, you're getting into what's called there's view matchers, view assertions, and view actions in Espresso, right? And so you're talking about view matchers, and so you can make custom view matchers. But the most lame thing you can do is just look for the text, like if you know the tabs have certain text. So you can find views, and everybody's laughing, goes like, "Oh my God, that's so horrible." But yeah, sometimes you can do that. You can just, but that's not great, right? Because if someday somebody's content has the name of your tab, then your tests are going to break. So maybe folks can help you. Someone can reach out to them after the talk. Essentially, what I'm trying to say is I don't know. I mean, you can use IDs, view IDs. You can use a text. You can, and you can also use data. I can't. It's not on the top of my head. I can't come up with a great answer for you.
No problem. Thank you.
Yep. Any other questions? Yes.
So it looked like at some point you had Jnit Test and Espresso Test running in the same class. How did you go about doing that?
Oh no, I didn't. No. Those tests you just saw, they were all Espresso tests. Frowny face. They were all Espresso tests. So, but if you look at that code I put up there, instead of just showing this silly thing, I should put the repo up there, right? Let me go back, and I think it's just really funny that I'm showing my presenter notes. Good thing I don't have notes like everybody around me is silly or something. Okay, let me go to this page, and I'll show you the link to the repo. Here it is. Is that it? No, that's it. Okay, so that's. Is that it? Yeah, that's the repo. Yeah. So I have a bunch of unit tests for the view model. So as you can imagine, I kept telling you what not to do. All of my business logic tests are in the view model, which is JUnit, and that's great, right? It's really fast. So they're different classes. Anybody else? You yawn. Is that a yawn? I saw a yawn over there. No, I'm kidding. Yeah. So your Espresso tests are in a different directory. So anyway, I think that's about it. We're going to hang out now and have some fun. I don't think the food's ready yet, but there's brownies up here if you want them. Anyway, thanks so much for coming, and I really appreciate your time.